Hi everyone. In this example, we're going to be sketching a curve that's based on this equation where we have a curve defined by some parametric equations and our range for t is going to be including 0 up to positive infinity. Now, first thing I like to do with these problems is just recognize that these components are my x, y, and z, and I'm going to write them out explicitly like this, just so that I can reference them a little bit easier. So we want to be able to get rid of this t so that we can draw a surface that we can recognize here. And I think the easiest way to do that with this one is to see that x squared plus y squared is going to be equal to cosine squared of t plus sine squared of t. And we know that cosine squared plus sine squared of anything is equal to 1. So what we have here is a cylinder. In 2D, this would be a circle, but since we're working in 3D space, this is going to define a circular cylinder. And that's going to have a radius 1. On my sketch, I'm just going to draw that cylinder. Okay, so here's the circle here in the xy plane, and that's going to extend infinitely in the z direction, both positive and negative. All right, so that's that cylinder there. What this is telling us, the fact that x and y have this relationship with each other, is that all the points of this curve must be on that cylinder. So that's going to help us with our sketch. I'm not going to sketch the curve on this one. I'm going to kind of use this as a guide for my next sketch here. Steps after this, I would say we can look at the range of t. And we'll say since this is our range for t, we can start by plotting t equals 0, since that's the beginning of our curve there. And we can also look at the remaining variable z equals t. So by noting that z is equal to t, we can see that the curve will travel up the cylinder. As t increases. That makes sense, right? Z is equal to t, so as t increases, we're just going to be vaguely traveling up that cylinder. In order to figure out the path that it's traveling, so we know it's going on this cylinder, we know it's going towards the positive z direction, we can plot some additional points. To show that the curve travels in a counterclockwise direction. So I'm going to give you another way to look at this afterwards. So just putting these points is maybe a little bit inconsistent way to figure out which direction this would be spiraling. So let's say as an alternative, we can use polar coordinates. To come to the same conclusion. So we'll show both of those ideas down here. Okay. So what I mentioned above there was my first step was going to be to plot t equals 0. So when t is equal to 0, I have my functions for x, y, and z. It turns out that t equals 0 is right here. Since we have t including 0, I do fill this point in. If you had strictly greater than 0, you would put a open circle here. But this is my t equals 0, and that is included. So this is my starting point, and like I said, I was going to plot some additional points. So I picked some things that were easy to plug into x and y. So those would be pi over 2. That has the coordinates, looks like this on the chart here. Pi would be over here, so sort of -1 in the x direction. And then if I added another additional point here, I would get 2 pi. This can be a little bit deceiving sometimes. It looks like from this that if you follow these points, as t increases, it looks like it's going to be spiraling up in this direction, but this can be deceiving. You might end up with points, if you don't space these out in the right way, you might end up with some points that give you a misleading direction. So the other argument using polar coordinates that you can use is to think about what this looks like from the top down. So this curve starts at this point here. So this is t equals 0. And we have that y is equal to sine of t. So what that's telling us is as we move along the cylinder, when t is increasing, that means y is also increasing. So we're kind of moving in this direction here. So again, plotting some points can help you with just getting the general shape of the curve that you're going to be drawing, but this is going to be much more consistent to kind of think about what a very, very small change in your x or y or z is going to produce in this curve. So using that argument, we can say that It's definitely going in this counterclockwise direction. So I'm going to sketch the curve like that. Again, all the points have to be on the cylinder, so I'm going to leave them on the cylinder there. We're not quite done with this yet. Another thing that we need to do is talk about the direction of this. So a curve contains this curve in 3D space, but we also need to give it a direction. So I like to draw a couple on here just to make sure that it's clear which direction it's moving in. So that's an important point. We need to include some arrows to show direction. And since our range started at t and goes to infinity, I think this arrow indicates that, but I just want you to recognize that this curve continues. The curve is going to continue infinitely because t is going to infinity. That's it for sketching the curve.